Good morning, my dear students. Welcome back to this session on cables subjected to point loads. So, last session I have told you to practice this problem and also the other problems like these two. Okay, so let's try this one, which is of JNTU KMI 19. Okay, check your solution. How we will get the solution if you follow this step-by-step procedure. Okay, right. So let me take uh, a paint page. So where I draw the problem, which is having now 2 meters, 2 meters, and 1.5. The same structure I can draw there. Okay, so just starting from here, see this level difference is 2 meters between the supports, and then the bottommost point is of 2 meters from this. Okay, right. So this has got some h distance from the left support. Right, so let's draw the support first here. Then from there we have to draw. I'll just go with the straight line so that looks okay. So about that, and next line something like a little flatter, and then the other one, so something like this. Okay, right. May not be to the scale, but you shall at least produce a similar one. Okay, right. Okay, the loads you see 3 kilonewtons and 8 kilonewtons. So some 3 kilonewton. This is something like 8 kilonewton. This is 3. This is 8 kilonewtons. Okay, right. Got it. Right. The geometry 2 meters and 2 meters. Here you see that this line, horizontal one, and this line denotes the this distance. Okay, and then the other one. Okay, right. So this is also 2 meters. Then the horizontal line means I shall draw this vertical line, and to that some horizontal lines. Okay, then this one. Right, so this has to be closed. Right, now let us see just a rough diagram I'm making, so that I don't take much time. This is 2 meters, 2 meters. Then how about the other geometry? 2, 2 and 1.5. So this is 2 meters, 2 meters. 1.5 meters. Okay, right. So now this distance, what the problem says is this distance is h. Okay, that you have to find. Got it? So, and the notations that you see, it's like A, B, C, D in continuation. C and B. Okay, right. So this is the given problem. So what it is saying to you, apply sigma fx 0. Okay. So what do you need to do first? You have to draw free body diagram. So remove the supports. Remove the supports. Okay. Just draw. I'll just make it clear. So remove the support. Okay. Then draw the forces which are okay. So there are the reactions at D and the reaction at A I'm making now. So reaction at A. So what are they? VA, HA, VD, HD. Okay. So apply sigma fx 0. That is the first thing to do. So sigma f x is equal to 0. So what do you see? You see only two forces, HA and HD. Okay. So HA is equal to, in fact, HA minus HD equal to 0. Okay. That will be your equation. Right. So from this, what you get, HA is equal to HD is equal to H. Okay. Right. What is the next thing to do? Take moments about A is equal to 0. This is E and A. So sigma m A0 you have to perform. Okay. Sigma m A is equal to 0 you should perform. Okay. So take moments about A is equal to 0. So all the anti-clockwise you make it as positive, clockwise negative. Okay. So that is the direction that we would like to follow. So anti-clockwise positive. So HA will become 0, VA into distance is 0, so moments are 0. 3 is clockwise, so minus 3 into distance is 2 minus 8 into distance is 4. Okay, then the other two forces, VD plus VD into 2 plus 2, 4 plus 1.5. 5.5. Also HD now is H, so is also anti-clockwise. So plus H into distance between A and H, 2 meters, is equal to 0. Okay, so it is like minus 6, 32. Okay, and plus this 5.5 VD. Okay, plus 2H. I'll just rewrite like this. So total 32 plus 6, 38. So what it becomes 5.5 VD plus 2 times H is equal to 38. Right, let it be some equation 1. Now what the other step? Equilibrium of joint D you have to perform. Okay, so what is joint D? This one. So to separate joint D, that you have to release this connection. So what happens? This will be TCD. Okay, so I'll write here. So it is like this one. HVD, and let it be some this extended horizontal and vertical lines. This. So let me just draw something like this. So this is your TCD. Okay. So the angle that this TCD is going to make with horizontal, you can get it from the dimensions you have. So this is the horizontal line, and this is also the same angle. Opposite angles are same. That's why you get this angle. From what? So this is theta CD, let us say. Theta CD. So tan theta is equal to, if you see this triangle, opposite side is 2, adjacent side is 1.5. Okay, so 2 divided by 1.5. So if you perform tan inverse, so theta CD will get a value. I'll just tell you the value. So tan inverse so you have to perform tan inverse of 2 divided by 1.5. How much is this? 53.13 degree. 53.13 degree. Got it? So this is how you get theta. Now, H, if you apply two equilibrium equations here, okay, what happens? Sigma Fx0 . So what is this one? It is like horizontal component of this one. It is this one vertical component of this one. So it is theta. So TCD cos theta. This is TCD sin theta. Okay. So let us substitute for this equilibrium equation. Sigma fx0 means right hand side h is there, towards left hand side TCD cos theta. So h will be equal to TCD cos theta. Got it? Right. Now VD is equal to, if this from sigma Fy0. Okay. So equilibrium equations. So VD shall be equal to TCD cos theta. I mean sin theta. Okay. Right. So you know the theta value already. So substitute it there. So what it will be, TCD into what is cos 53.13. Okay. So cos 53.13 degree is 0.6. Okay. Similarly, TCD sin theta value, you can get it. So sin 53.13 degree, it is 0.8. So sin 53.13 degree. So 0.8 is the value. Okay. Right. So this is H value and VD value in terms of TCD. So that these two values you substitute in one. Okay. So that is what is the next step that you have to perform. You see. So we have taken equilibrium of giant D, and then we wrote H and VD in terms of TCD now. Now substituting, we are going to substitute H and VD in equation 1 to get TCD. Okay. So that we are going to do. So 5.5 times of 5.5 times of VD means what? TCD 0.8. 0.8 TCD plus 2 times H. 2 times, what is H? 0.6 TCD. Okay. You do it parallelly along with me if you have not done earlier, or else whatever you have done, you now cross check with my calculations. Shall be equal to 38. Okay. Right. So both the terms TCD is common and it is the unknown. What is 5.5 into 0.8? So 4.4. So 4.4 plus 2 times 0.6. 1.2 TCD is common is equal to 38. Right, what is TCD now? This is what? So 38 divided by 5.6. 38 divided by 5.6. 6.786. 6.786. It is 6.7857. I have rounded off to 3 decimal places because it is in kilonewtons. So you must maintain 3 decimal places. Right. So that is TCD value. Now what? You got TCD value. Substitute this TCD in the relations for the H and VD, so that you will get H value and VD value. See, so TCD value, now you know the value, so you can get H value. So H is equal to, what is it, 0.6 times of TCD. What is the value? So 0.6 times of 6.786. So 4.072. 4.072. It is 0716. I have made it to 3 decimal places. Round it off. Next, what is the VD value? VD is nothing but TCD into 0.8. So 6.786 into 0.8. It is 5.429. It's 5.429. It is actually 5.4288. So I have made it to round it off to 3 decimal places. Okay, got it? So this is how we perform this TCD value. I mean this cable tension in the last segment, and H value, that is horizontal reaction at both the supports. HA is equal to HD, and also vertical reaction at D, we have got it. Right, then what? So from the vertical equilibrium, okay, sigma Fy0, we can get VA value. That's very simple, right? What is sigma Fy0? Okay, so write it here for the whole free body diagram. What is sigma Fy0? Sum of all vertical forces, that is VA plus VD is equal to downward forces 3 and 8. Okay, 11. So what is VA we want? Already VD you know. It is simply 11 minus 5.429. Okay. So 11 minus 5.429. It is 5.571. 5.571. Okay. So this is VA value. See, so what we have solved till now, all the 4 external reactions, HA, HD, also VA, VD, this is VD, VA, both the H values. Also, along with them, we have solved for one tensile force in the cable, that is in the last segment. Okay, right? So we will proceed further to the further steps, like to calculate what is TAB and theta and how to get H value, and then how to get the other unknowns, like the other segments, tensile force in the other segments. Okay, right. Thank you.